The idea of a coordinate system, where we can represent the location of a point in space using numeric coordinates, was the invention of René Descartes back in the 17th century and is the basis for all of what today we call analytic geometry. So to represent the location of an object in two dimensions, we're going to start by drawing two lines that are perpendicular to each other, called the coordinate axes. The horizontal axis is called the x-axis. The vertical axis is called the y-axis, and the point where the two axes cross is called the origin. Now, if P is a point somewhere in the plane, then we'll define the location of the point based on its directed distance from each axis. Right? That is, the distance from the y-axis is positive if the point is above the x-axis, and it's negative if the point is below the x-axis. Similarly, in the x direction, if the point is to the left of the y-axis, we'll say its x-coordinate is negative, and if it's to the right of the y-axis, we'll say it's positive. Together, these two values, written with the x distance first and the y distance second, make what's called an ordered pair, and that uniquely defines the location of every point in the coordinate plane. So for example, the lower point here, in the lower right, its coordinates would be 6, negative 5, and the point in the upper left, its coordinates would be negative 6, 7. Now, this method for pairing points in a plane with a pair of real numbers, called the coordinates, is what we call a rectangular coordinate system. So I've got some points here for us to take a look at, right, and think about what their coordinates are. So looking at this upper point here first, to get to that point, we don't have to go anywhere in the x direction. We just go straight up. So the x coordinate of that point is going to be 0, and the y coordinate is going to be 8 because we have to go 8 units above the x-axis to get to it. Now, similarly, this point over here to the far right, we have to go 7 units over to get to it. So the x-coordinate is going to be 7. And we don't have to go up or down at all. So the y-coordinate of that point is going to be 0. Now this point down here, that one is going to have some non-zero coordinates. We have to go 6 units to the right of the y-axis and 4 units down from the x-axis. That's going to make the coordinates of this point 6, negative 4. And finally, this point over here, we're kind of going clockwise. This point in the lower left, to get to that point, we have to go 5 units to the left of the y-axis and 6 units down from the x-axis, making the point's coordinates negative 5, negative 6. And finally, we have this special point here that we picked out on the last slide. It's the origin. The coordinates of the origin are always going to be 0, 0. We don't have to go up or down to get to it. So the next lecture, we're going to investigate some of the properties of points that are in this coordinate plane. And the first thing we're going to talk about is how to find the distance between 2 points. And that's going to be just a fundamental concept that is going to underlie practically everything else we're going to talk about throughout our whole analytic geometry conversation.